In this video, I'm going to show you how to compute basic indefinite integrals of trigonometric functions. We've got all the derivative rules for the 6 trig functions written down here, and we'll use these rules to come up with integral rules for these trig functions. So starting with the derivative of sine is cosine, if we reverse that, then we know that the integral of cosine is just sine. Likewise, since the derivative of cosine is negative sine, then we know that the integral of sine has to be negative cosine. Going forward, since the derivative of tangent is secant squared, then we know the integral of secant squared just has to be tangent. Likewise, since the derivative of secant is secant tangent, then we know that the integral of secant tangent is just secant. And then since the derivative of cosecant is negative cosecant cotangent, then the integral of cosecant cotangent x is just negative cosecant x. And then since the derivative of cotangent is negative cosecant squared, then the integral of cosecant squared is just negative cotangent. So really, as long as you remember the derivative rules here, then you can just flip them around to get the integral rules. Here's an example, and here we want to go ahead and apply those rules that we've learned previously to compute this larger integral, the integral of sine x plus 2 cos x minus 3 secant squared x. And how we're going to do this is we're going to break it up over each of these terms here and compute separate integrals for each of the terms. So let's start off with integral of sine x, integral of sine x dx. Let's go ahead and write out the rest of the integrals as well. So next up is integral of 2 cos x, so plus integral of 2 cos x dx. And then lastly, we've got our integral of negative 3 secant squared x, so plus integral of negative 3 secant squared x dx. And to clean that up a little bit, let's go ahead and write that again, but let's move all the coefficients in front of the integral so we just have the trig functions inside of the integrals. So integral of sine x dx, that stays the same, but in this integral of 2 cosine x dx, let's move the coefficient in front, so plus 2 integral of cosine x dx. Same idea with that next integral, so pull out the negative 3 minus 3 integral of secant squared x dx. And now we're ready to solve these integrals. So let's start off with the integral of sine of x dx. Think, what gives you a derivative of sine? Well, that's cosine, but that gives us a derivative of negative sine, so we've got to introduce a negative in front. So integral of sine is negative cosine of x. Okay, let's keep on going to the next integral. So plus 2 times the integral of cosine x. What's the integral of cosine x? Well, what gives us a derivative of cosine x? Well, that would just be sine. So 2 sine of x. And then lastly, minus 3 integral of secant squared x. What gives us a derivative of secant squared x? Well, that's just tangent. So tangent x is our integral. And there we go. Now we're done. Just add our constant of integration at the end, plus c. And here is our indefinite integral. Alright, here is another indefinite integral for us to compute. We want to compute integral of 5 secant tangent minus 7 cosecant cotangent. Alright, so again, let's just go ahead and split up the integral over these two terms here. We'll have this term first, and to speed things up, let's just go ahead and pull out the coefficient to begin with. So 5 integral of secant x tangent x dx. And then the next term is minus 7 cosecant cotangent. Again, we'll pull out the coefficient in front, so minus 7 times the integral of cosecant x cotangent x dx. So now it just remains to actually compute these integrals. So let's start off with this secant x tangent x. The integral of secant x tangent x, well, what gives you a derivative of secant x tangent x? That's just secant. So the integral of secant x tangent x is just secant x, and keep our coefficient in front, 5 secant x. Same idea with the other one. So minus 7 times the integral of cosecant cotangent. What gives us a derivative of cosecant cotangent? Well, cosecant gives us a derivative of negative cosecant cotangent. So we'll just write down that cosecant, but put a negative on it because we want to cancel out the negative inside of this integral. And then put our plus c at the end. And now let's just go ahead and simplify. So we have 5 secant x, then minus 7 times negative cosecant x. Both these negatives cancel, and we've just got plus 7 cosecant x plus our constant of integration. And there we have it. We're done. All right, here's our final example. We want to compute the integral of cosecant x times the quantity 2 cosecant x plus cotangent x minus 5 sine x dx. Okay, so we'd like to do the same strategy here. We'd like to break up our integral over all of these trig functions, but right now we've got some multiplication going on. Cosecant times a whole bunch of things. So why don't we go ahead and just multiply out this integral first, and then we'll break it up. Okay, so multiplying it out, we've got integral of cosecant times 2 cosecant. Well, that just makes 2 cosecant squared x, and then plus cosecant times cotangent, so that just stays as cosecant x cotangent x, and then cosecant times negative 5 sine x, so let's write that down, minus 5 sine x cosecant x. And that's all an integral with respect to x. Now, before we go on, one thing that we can do to simplify this even further is to notice that cosecant can just be written as 1 over sine. So this term just becomes 5 sine x times 1 over sine x, and that'll cancel with the sine, and then we'll just be left with 5. So let's go ahead and write that out once more, just having that 5 over there. So integral of 2 cosecant squared x plus cosecant x cotangent x, and then just minus 5 all dx, and that looks about as simple as we're going to get it. So let's go ahead and split up this integral. So first of all, we've got our cosecant squared term, so that goes to 2 integral of cosecant squared x dx, and then we've got our cosecant cotangent term, so plus integral of cosecant x cotangent x. And then lastly, we've got integral of negative 5 dx. Okay, so now let's just compute these. So integral of cosecant squared, well, what gives us a derivative of cosecant squared? That's just cotangent, but cotangent gives us a derivative of negative cosecant squared, so we have to introduce a negative sign on that cotangent, and that's all being multiplied by that coefficient of 2. Okay, and then integral of cosecant x cotangent x, what gives us a derivative of cosecant cotangent x? That's just cosecant x, but cosecant x gives us a derivative of negative cosecant cotangent, so we have to add on an additional negative sign to cancel out that negative because we want positive inside the integral. So plus that, and then, okay, this last integral is really easy. We can just apply the power rule for integrals, so just plus negative 5x, and then plus our constant of integration. And let's just go ahead and clean this up. So this is negative 2 cotangent of x, then minus cosecant of x, then minus 5x plus our constant, and there we have it. We're done. Now we know how to compute basic indefinite integrals for trig functions. And in the future, we'll also learn how to compute basic definite integrals for trig functions as well.